So, hi everybody, welcome to ChangeCon. It's been a great day so far. It's going to be tough to follow up Dalibor's talk. He went really in depth about database performance, and I'll be talking a bit more about performance in general and handling performance in your development process. So, I've been at Kidding ICT for 10 years. I'm currently head of development. But I grew up as a developer. I'm a developer at heart, specifically a C# developer. So, let's get into this little thing called performance. Before we start, I got some advertising to do. So this is a book Rocco and I wrote about agile software delivery. It's the first such book in creation, so you can buy it outside. It's really good. It helps a lot. We're going to probably make it mandatory in our company, so everybody has to buy it. So let's get back on topic. Which is faster? I'm sure a lot of you came across questions or statements like this. I especially love the last one because that was a source of a few religious wars. People commenting that the Java or C# is better. Yeah, that's my kid, by the way. So that's his first IT conference. Anyways, all of these statements are pretty definite. So count will always be slower than any. String builder will always be faster than string concatenations. For will be pretty much faster than for each, and stuff like that. And the last statement is kind of special because it doesn't have any definite answer. Each language will be faster in a certain degree in certain circumstances. Another language will be faster in other circumstances. And that's because, and that really doesn't matter because the speed of your application or the performance of your application isn't in the language. It's how the developer uses that language to produce your system. And all in all, when you look at these statements, you come to the conclusion, yes, one of these is faster than the other. And sure, but how much faster? Is that microseconds, milliseconds, whatever? Because if you don't run string builder 1,000 times on each user request, then those few milliseconds saved by using string builder instead of string concatenations won't matter. And if you use it 1,000 times in a single call, it's gonna do some. It's something better, but if you just call this stop procedure method only once, it's not going to do any difference. So when you take all of that into consideration, you know what? Who cares? This doesn't matter. This is completely useless, and discussing about this is completely useless. And as Voltaire said, the perfect is the enemy of the good. That means that focusing on squeezing a few milliseconds from your code and doing such optimizations makes you lose the context. And losing the big picture while perfecting and polishing your little piece of code really does nobody good. So a few milliseconds or microseconds really don't matter in the grand scheme of things. Does that perfection, that we strive as developers matter to our consumers and our customers and to the system that we're trying to build? And the truth is, it really doesn't. As odd as it might seem, it doesn't. At least most of the time, don't get me wrong. If you're doing some, IoT, Raspberry Pi, high volume systems, it might matter, but in most line of business apps, it doesn't matter. Because most developers, including me, work on line of business apps. And apps that directly contribute to consumer transactions, business needs, and user experience isn't that much dependent on performance and on system performance. Rather, it depends on getting the user requirements right. So we have a lot of large-scale enterprise solutions, so on, which have like thousands of features. And for our end users, it's much more important that those features work correctly and calculations and whatnot, than for them to be extra speedy and to save them a couple of milliseconds on every single click. So when building, regardless if you're building a feature or a system, make sure you get your priorities right. So focus on doing stuff in the right order in order that provides the most value to be delivered to your customer. In fact, trying to do micro optimizations of this type on these kinds of applications actually hurts your team as the time spent trying to implement those micro optimizations could be better used to implement core requirements of the system. And so when you build your system, make sure to make it work first. So let's say you make sure it passes tests and implements user requirements correctly. Next, make it right. So make it sustainable, make it maintainable, make the code look nice so everybody can read it and stuff like that. And in the end, then make it fast. So if your code doesn't work, then change it. If your code doesn't fulfill the customer requirements, then change it. If the code doesn't meet team coding standards or something, then change it. If you think the code is slow, then first prove it. And if you can't prove it, then don't touch it. Unless you can really prove that performance matters, then it doesn't, and you don't need to change anything. So, yeah, and performance doesn't matter until it does. Right, you have two roads. One is congested, one is not congested. Which one would you pick? I'm guessing, for our everyday commute, you would pick the road on the right, so it's an easy answer. And that's what's problematic about performance. So the truth is that system performance is an integral part of our user experience, and as such, it's always at the core of some kind of customer expectations. And once the system performance decreases so much that it degrades the user experience, systems are quickly dismissed by the end user as unusable, and they will have considerably lower value to the end user, and the customers will try to replace them. This is evident by our daily commute to work, where we will always abandon the slower congested roads and pick the faster open roads, as the performance of the slower congested road impacted our user experience driving to work. So our users don't really care about micro optimizations, whether we use 4 or 4 each, the same way as we really don't care about the impact of surface friction on the road we're driving on. We just want to get to our intended goal as fast as we can. So our customers care about overall performance of our design, or overall performance of our system, and the speed at which they can reach their goal. So you would like to, you pick your nice little design, your open road you want to use, but what happens when it's too late to pick that design? The problem with feature or system performance is that when you need it, you can't just add it in. So you design the road with 4 lanes and you need 6 lanes, and you just can't glue 2 more lanes to it. It doesn't work. So poor performance is usually design or process failure, and to have a performance system, performance must be considered as an end user requirement the same way as any other requirement. So we need to change how we think about performance, and not as an afterthought, rather than as a core feature of our design. It is not about micro optimizations, it's about the user experience and the overall system performance. So our micro optimizations don't matter if you don't get the overall design right. So performance is a part of the user experience and a feature in itself of the system, the same way as good user interface design. It is not a set of non-functional requirements or something that we can put in the system afterwards. If we have to add it in afterwards, it's going to cost a lot of time and effort doing rewrites of the design, just chucking everything out and putting new designs in and stuff like that. So it's really not worth it. So when we start to treat performance as a feature of our design, we need to start thinking of working it in our delivery process. So, since 3-letter acronyms are pretty popular these days, so let's say we have performance-driven development, and it came up a couple of years ago, now it's getting more traction. So how do we get started with performance-driven developments? Is the same way we got started with something like test-driven development and stuff like that. We started by setting up some benchmarks on our design, the same way as you would set a minimum code coverage or any other benchmark on your piece of code. And you should set a minimum performance acceptable SLA for your piece of code, even if your client doesn't have any requirement towards you. You should set it just for yourself. So let's say it's 5 seconds of request, whatever. Just set something minimum so you can check it and run stuff against it. And don't go for the easy blanket ones, like 3 seconds on every request, and because that really doesn't mean anything. That's just the easy way out. You have to define the SLA based on your feature, on your process, specific to what it means to that process. So for some instances, it might be some request response times. For some instances, it might be JSON response size. For some instances, it might be number of requests, number of rows read from the database, etc. Now you have to pick what makes the most impact to that feature and signals that that feature is okay. So to monitor, of course, when you set up those benchmarks, you have to monitor them. And to monitor your performance SLAs, you need to set up performance indicators and monitoring hooks directly in your design. So you will need them during tests and production phases to figure out what's going on in your system, to figure out how it's behaving under load. And profiling tools and monitoring tools are really great, and you should use them in operations, but they're really not there to be your primary source of information. If you open up a performance system monitor in Windows, you will probably see there's like 1,000 different measures in it there, and it's from .NET, SQL Server, OS, depending, Oracle, whatever, and none of them is from our own applications. So we should really build them in and monitor them from the system tools, and leave the profilers and monitoring as a last resort. So to make all of your benchmarks meaningful, you really need to know how your system scales from test to production environments. And the best thing would be if you had a production environment replica one-on-one that we can use as testing environment, but let's face it, that's not going to be the case most of the time, and we can't have that. We'll always have some scaled down version or something, and missing components, less hardware resources, mocked services, whatever. And that's where your scaling factor comes in. So scaling factor, and both scaling factor and performance boundaries. So to get your scaling factor, you really need to know the environment as a system to the last layer, because scaling doesn't depend just, let's just increase the amount of CPU or whatever cores or something and we're done. It really depends on two things. How much does your least scalable component scale, and how scaling of each component impacts the load of other components. So for instance, when you run performance test and testing environment with a certain number of requests, everything is good, works great. Moving to production, you scale up your CPU, RAM is your primary concern to proper levels, and you go home and sleep well, and you said, I've done a good job. So when production loads hit, you're suddenly in trouble because your disk is overloaded. What happened? Somebody in the team says, that logging thing we added on those 1,000 requests we ran in testing environment, the disk I/O was okay, but at this level of 100,000 requests we were running in production, suddenly we didn't scale the disks to, I don't know, some kind of great level, and it doesn't work anymore. So we scaled one part of the system, we didn't scale the other part of the system, and it fell over. So the point is that when you unplug a bottleneck on a single component, suddenly you will get hit by unexpected bottlenecks somewhere else, like your routers falling over from loads, disk getting hammered from logging, network interfaces that don't have enough bandwidth. So the key to scaling is to figure out where the next bottleneck is going to be, and to see if you can live with that next bottleneck. So when you get all that in place, now we need to go on lines of TDD. So if you're really trying to improve performance, TDD becomes an instructive model, how to do that. We want the performance specialist to be integrated in the team, and not only that, we want everybody on the team to be the performance specialist, so it's not a special role or something like that. And we want them to work on the most current releases, and we want them to use real customer workloads, and we want the tools they use to be a part of the development process rather than something we do 2 hours before pushing to production and just, let's benchmark something. So we really want performance to be a part of our development process. Of course, we need a way to implement performance testing with as little effort as possible, and one of the cheapest ways to do that is to just measure your existing TDD functional tests, whatever you got, just measure them and time them and see how your system behaves under load. So if you already built in some performance indicators, you can use them to tell you what's going on in the system under load, and get some real data from that. And finally, you need to always have in mind end-to-end user experience, and end-to-end user experience must be measured, because, like I said before, that's what counts. Everything else, partial functionality, partial speed doesn't count. End-to-end user experience counts. So tools like Load Runner, Rational Performance Test, Selenium, JMeter, Visual Studio Test, whatever, whatever can simulate user behavior on web, on desktop, or whatever, you should use it to measure end-to-end user experience, to get a sense how the user will see your application. And you should, of course, try to include it in your CI process, but you should be careful about it because you probably want your builds to be short and fast for the CI, and you don't want a bunch of load tests just taking hours to complete. So you should probably just set up a couple of smoke tests for performance in your CI build and include everything else in some nightly, weekly, or some build, but just try to keep that feedback loop as short as possible. So once we get to the production environment, you, of course, start focusing on the operations and on operations perspectives. And when talking about operations in general, and specifically for performance, you have three basic tasks. So you seriously don't want to be the guy that finds out last that you have performance or problems, whatever. And you just don't be that guy. So there are dozens of ways you can monitor every part of your system, even if you don't have built-in performance indicators. And use monitoring software, which is abundantly available from New Relic, Caps Insights, various others. There's just a bunch of them out there. And finding out first that you have deteriorating system performance gets you ahead of the curve, and you can actually do something before your users start complaining. So you should get that time and use it well. And lots of times we just see the system is slower and slower, or we can get suddenly hit with a poorly responsive system. But regardless of the manifestation, you can always be assured that somewhere in the system, be it in your application, the OS, the host, the client, you will always have some indication that the system is not working right, and the system will be able to tell you where things went wrong. So you just need to be able to read it and understand what the system is telling you. So get the symptoms, read measurements, work the problem using whatever, probe scans, whatnot, whatever you can do. So it is imperative for the operation staff to understand the performance indicators that the system has, to be able to take the advantage of the time gained by being the first guy to know. And of course, at the end, you have to plan for these sort of issues, to be that you scale up, scale out, cut less used features, even cut off some clients. So you have to make a plan and have that plan ready to work with it. So you will undoubtedly hit a problem. So what happens when you hit a snag? Bottleneck, performance issue, whatever, and what to do. So different architectures are prone to different problems. Microservices are, for example, prone to request fan-out problems, and other architectures have their specific problems. But regardless of architecture, or even if you know it well, you really shouldn't lose your head. Don't panic. So go back to basics, start working the problem, and check the symptoms. Start reading the system. How is your CPU RAM, disk queue length, network bandwidth? How is your host doing? Is it just your VM that's under load, or is it the entire host that's under load, etc. And try to narrow down your list of likely culprits by any means, and then check those first. Check the performance indicators, profile them, and if you get nothing, expand the list slowly. So, if you all saw the tool that Dalibor showed, that's a great way to have performance indicators in your system, which you can use quickly to identify where you have a problem. And of course, profilers are your best friend. Be it C#, Java, network, database, whatever. Profilers are great. And whenever in doubt, use profilers. And profiling can show you all sorts of issues, but the key thing is knowing where you need to profile. So if you read performance indicators correctly, and if you read what the system is showing you, you should have some idea to know where to look and what to profile. And of course, when profiling, always profile from the consumer perspective, and be careful not to lose their perspective, because, like I said, some architectures are prone to let's say, fan-out problems. And in this kind of situations, on the surface, everything's going to be looking great. Every service is going to be looking great. Every team is going to say, yeah, we're doing great. We're serving up those requests in 50 milliseconds flat, and we're okay, no problem here. And still, the client response times will be slow. So what happened is that you lost perspective on the system as a whole. Nobody noticed that one user click generates 100 requests across our system, and even if all of those requests are handled 50 milliseconds at a time, 100 requests will still total in 5 seconds of response delay to the consumer. And in other scenarios where you have a lot of database logic and procedures, just go straight to them and profile them to figure out what's going on, read the database engine and about your queries and overall database performance. But this is really where your planning and knowledge about the system architecture and overall system perspective gives you the upper hand in the race against time. So when you figure out what's wrong with and where you have a problem and you have to fix it up, so you should really treat performance as like any other bug or any other feature. So poor performance is a bug in the user experience feature and should be handled pretty much in the same way as any other bug. Some bugs can be mended with little intervention in the system, while some require extensive process implementation redesign. And so if you can make a quick improvement to help the situation along, make it. Then feed the situation back into your PDD lifecycle, building a performance regression test. Cover that edge case with a suitable barrier of tests and satisfy those tests to redeploy your solution. So the key is to treat your performance issue as any other bug that you would feed for your TDD lifecycle, just you have to feed it here for the PDD lifecycle. And in the end, I would like to leave off with a quote from Gene Kranz, who was a long-time NASA flight director, a guy who knows a thing or two about operations. He made this quote during the recovery of Apollo 13, and from the operations points, it's really, really important to remember this. So let's work the problem and not make things worse by guessing. Nothing can be fixed by guessing or worrying about it. So use performance-driven development, implement indicators, understand your environment, implement tests, and work the problem systematically to come up with a life-saving solution. Sure, working the problems and implementing a fix will cost effort and time and stuff, but performance is a feature, and it's time to start treating it like one. Make it a first-class citizen in your delivery process, and use your delivery process to drive performance in your system. And I think that's it. So, questions? Comments? Objections? Something? No? I wouldn't go that far, come on. You have to be modest. So, no? Okay, so if there are questions, I'll be outside and we can talk if you're, same thing as Dalibor. If you don't want to ask, I'll be outside and we can talk about it later. So thank you very much and see you around.